everybody, in this video I'll introduce the loan formula and we'll compare the loan formula to the savings annuities formula that we've already learned about. So take 3 deep breaths and let's make this math easy. Okay, so in the loan formula, we have 5 different variables, and they're pretty much the same as the variables we've already worked with. So P is the loan amount that you borrow at the beginning. So we've been using P to represent the beginning amount in all of our equations so far, and we're going to keep that consistent in the loan equation. Then R is the annual interest rate, K is the number of compounds per year, and D is the payment amount that you make within each of those compounding periods. So for the most part, we're always going to have K equal 12 because we're going to do monthly compounding, and we're also going to have monthly payments. So in the savings annuities formula, D was the monthly deposit you were making in the savings account. With the loan formula, D is going to be the monthly payment amount that you're using to pay off the loan. And then T equals the number of years. So if you look at the savings formula versus the loans formula, you'll notice that they're very, very similar to each other. And this makes sense because both of them are either giving or receiving payments every month or every compounding period. And they're basically just working in opposite directions. Like the savings account, you start with $0 and then you deposit a monthly amount until you build up to an ending amount that's a big number. With loans, it's the opposite, where you start with a big loan and then you slowly pay it off month by month until you end up at 0. And so the things that are similar between these equations are the interest rate calculations, because you're taking your annual interest rate and dividing it up into the number of compounding periods, again, usually monthly. So that part calculates the monthly interest rate, and then you add 1 because you'll still have 100% of your previous calculation. And so that part is the same in both equations. And you also have that monthly interest rate that you're dividing by in both equations. And the things that are different between these equations are that in the savings formula, you subtract 1, and in the loans formula, you do 1 minus that information. And there's also a difference where the loans formula has a negative exponent for the interest calculation, and the savings one has a positive exponent. So that's another thing that's slightly different. And I talked about this a little on the last slide, but in the loans formula, D is a monthly payment that you're using to pay off your loan. And in the savings one, D is a monthly deposit that you're using to build up your savings. So they're both monthly payments, which was why I called them both D. But savings are basically increasing your overall amount versus the loans, you're paying off your loan. So they're decreasing the total amount you end up with. And this also shows us why we have 2 different variables that the equations are equal to. Because in a savings account, your initial amount is always 0. You start off with $0 in your account. And so it doesn't really make any sense to have P in our equation because P is always 0. But eventually you build up to a large amount at the end. Versus with loans, it's the opposite. By the end of your loan, your amount that you end up with should be 0 because you're paying off all of the loan that you borrowed. But the initial amount will not be 0 because you're starting off with a large loan amount. And so in the loan formula, P is going to be the original amount that you borrowed. So when you're using the loan formula, just like with the savings annuities formula, you need to make sure that you follow order of operations. So you'll start off with your innermost set of parentheses and you'll simplify that. And then you'll raise it to an exponent and subtract it from 1. And then once you have that number, you can multiply by d and divide by the fraction. Or you could divide by the fraction and then multiply by d, because it doesn't matter whether you multiply or divide first with order of operations. So you can do it in either order depending on what you think is easiest. So in the next few videos, I'm going to show you how to calculate various things with this loan formula. So I hope you guys have a good day, and I hope this was helpful for you.